tend to imagine distance as a kind of emptiness. The farther something is, the dimmer it should be, the simpler it should be, the less there should be to say. But the farther Webb looks, the more that comforting picture begins to fail, because one of the galaxies it has found is not just far away. It is so far away that we are seeing it from a time when the universe was barely beginning. And what makes that unsettling is not the distance itself. It is that this galaxy already seems too active, too bright, too developed for how little time had passed. Stay with me, because by the end of this, the night sky may feel much less quiet than it does now. And if you enjoy calm, deep space journeys like this, you can subscribe and keep this one nearby for the next late night. Now, let's begin. The easiest place to start is with something we think we understand. When you look at the moon, you see it as it was a little over a second ago. When you look at the sun, you see it as it was about 8 minutes ago. That already tells us something strange about sight. Vision is never truly present tense. Light needs time to travel, and the universe is large enough that even ordinary looking can become a kind of archaeology. Stretch that outward and the effect becomes harder to hold in the mind. The nearest stars are not seen as they are now, but as they were years ago. Some stars in our own galaxy are shown to us as they were when entire human civilizations were younger. Distant galaxies are older still, not because they aged more slowly, but because their light began its journey so long ago that it has been crossing expanding space for most of cosmic history. That means a telescope like James Webb is not only a machine for seeing far, it is a machine for seeing early. And that is where the emotional center of this story begins to shift. Far away sounds like geography. Early is history. Suddenly we're no longer talking about remote objects floating somewhere out there. We are talking about the opening moments of the universe, caught in the act. A lot of people stop at that point and think the wonder is complete. A galaxy from the dawn of time. Incredible. But the real tension begins after that. Because if you go back early enough, there are things we expect to find and things we do not. We expect youth. We expect roughness. We expect the first structures to be small, dim, chemically simple, still fighting their way into existence. We do not expect them to look as though they have already been busy for longer than the clock seems to allow. That is why this discovery matters. One of the galaxies Webb helped confirm, known for a time as the most distant securely identified galaxy, is seen from less than 300 million years after the Big Bang. Another later result pushes that confirmed frontier even a little closer to the beginning, to roughly 280 million years after it all began. Those numbers are easy to hear and hard to feel, so it helps to compress them. Imagine the entire age of the universe reduced to a single calendar year. In that version of reality, these galaxies appear in the first days of January, not spring, not summer, barely after the new year. And already, the lights are on. That is the part that should make you sit a little more still. We are not looking at a universe that is calmly preparing itself. We may be looking at one that was building faster than many of our earlier expectations allowed. The question is no longer just, how can Webb see this far? The question becomes, what exactly was already happening back then, and how did it happen so quickly? To feel the force of that, it helps to picture what scientists thought they were stepping into before Webb began returning data. Not ignorance, not darkness in the absolute sense, but a very young cosmos still emerging from its hotter, denser origin, still assembling its first generations of stars and galaxies, still filled with large amounts of neutral hydrogen gas that made space harder for certain kinds of light to cross. The first few 100 million years was supposed to be a difficult era. Productive, yes, but difficult. Slow enough that the earliest galaxies should often be faint and scarce. Think of it like opening a massive nursery before sunrise. You expect outlines, maybe a few structures, a sense of beginnings. What Webb has sometimes revealed instead is more like finding neighborhoods already under construction, windows glowing, smoke already rising from the chimneys. Not a finished city. No, but much more activity than many people were prepared for. Now, there is an important distinction here, and it matters for keeping this story honest. Astronomers are not saying the universe makes no sense. They are not saying everything before Webb was useless. They are not saying one telescope has overturned all of cosmology. That kind of language is exciting for a moment and then collapses under its own exaggeration. What they are saying is subtler, and in some ways more interesting. The first chapter of galaxy formation may have moved faster, or more efficiently, than many models had anticipated. That sounds mild until you live inside it for a moment. Because speed in cosmic history is not just speed. If a galaxy becomes bright unusually early, that implies stars are forming rapidly. If it shows signs of heavier elements unusually early, that implies stars have already lived long enough to forge those elements and return them to space. If its environment looks strongly ionized, that implies it may already be affecting the gas around it. Each of those is a clock. Each one says time has already been spent. And when several clocks begin pointing in the same direction, the pressure grows. That pressure begins with light. Webb does not just look at these galaxies and guess how far away they are from a blurry image. It works in infrared, because the expansion of the universe stretches ancient light into longer wavelengths. Light that began as ultraviolet or visible long ago can arrive as infrared by the time it reaches us. Webb can detect that. More importantly, astronomers can spread that light out into a spectrum and read its redshift, a measure of how much the universe has stretched it along the way. That is how the great distance is secured, not by mood, not by artistic impression, by light carrying the record of its own journey. And once that journey is measured, the next question becomes impossible to avoid. What kind of object are we actually seeing at the end of it? A weak little seed? Or something that has already advanced farther than comfort would suggest? In one of the best-known cases, the answer did not stay safely modest. The galaxy was not merely detectable, it was surprisingly luminous. Not huge in the way a mature modern galaxy can be huge, but bright enough to raise eyebrows almost immediately. Brightness here matters because light is a kind of accounting. It does not tell you everything, but it tells you that something is happening. Energy is being produced, stars are forming, matter is gathering, history is accumulating. That is the first troubling question hidden inside the title. Not, how did Webb find a galaxy so far away? But why does a galaxy that far away already seem so alive? And once that question enters, the silence of the early universe starts to feel less certain. It is no longer a clean darkness waiting patiently for structure to arrive. It begins to look more like a place where structure may have rushed forward before our intuition was ready for it. Like the first few minutes of dawn when you expect only a grey horizon, and instead find that the room is already full of shapes. If that were the whole story, it would already be enough to hold us. But it is only the edge of it, because brightness is just the first sign that the timeline may be tighter than we thought, and the next signs go deeper into what this young galaxy seems to contain. When astronomers began looking more carefully at one of these ancient systems, they did not just see a remote glow. They found evidence suggesting that the galaxy had already assembled a substantial amount of stellar mass remarkably early. That matters because mass assembly is not an abstract phrase. It means stars are not appearing one by one in a leisurely trickle. It means a meaningful collection of them may already be there, packed into a very small region, producing light with surprising efficiency. Try translating that into something more physical. Imagine expecting a few candles flickering in a distant field and discovering something closer to an industrial district, all of its energy compressed into a footprint small enough to make the brightness feel even stranger. Size alone would not trouble us. Brightness alone would not trouble us as much. But brightness from a compact region this early begins to feel accelerated, almost impatient. And that feeling only grows when we start asking what kind of material this light is passing through. Because the next troubling question is not about distance at all. It is about maturity. And maturity, at the dawn of cosmic history, is a much heavier word. There is a simple idea that helps here. Right after the Big Bang, the universe did not contain the full chemical richness we are familiar with today. The earliest matter was mostly the lightest ingredients. Heavier elements had to be made later, inside stars, and then cast back into space by stellar death and stellar winds. In other words, chemical complexity takes time. It is the ash after the fire, the smoke after the flame, the metal in the soil after earlier generations of stars have already lived. So when an extremely early galaxy begins showing signs consistent with metal enrichment, even if the details remain under study, the emotional force of that is immediate. It is like entering a room where you thought the first match had barely been struck and finding soot already on the walls. Something has already burned. Something has already happened before the moment you thought you were arriving. That is where the story deepens from impressive to quietly disorienting. And once you feel that shift, the next step becomes unavoidable. If some of these galaxies are not just present, but already chemically active, what does that say about the opening hundreds of millions of years as a whole? It suggests a universe that may have wasted very little time. A universe that wastes very little time does not feel the way most of us imagine beginnings. We tend to picture beginnings as gentle, sparse, unfinished, a child's sketch, a few lines waiting for the real image to arrive. But Webb keeps nudging us toward a different emotional picture. The first few 100 million years may have been less like a blank page and more like wet paint already spreading, forms appearing while the canvas still feels new. That is why the chemistry matters so much. Not because oxygen or carbon or ionized gas are glamorous words on their own, but because they are evidence that time inside these systems may have been running hot. Stars had to form, some had to live fast, some had to die. Their surroundings had to change. Light had to pass through environments that were no longer purely primitive. In ordinary language, something had already been building history. And history is the thing we thought there would be less of. It helps to stay close to the human frame here, because otherwise the numbers can become so large or so early that they stop feeling like anything. If the age of the universe were compressed into a single human lifetime, these galaxies belong to the first breath after birth, not childhood, not adolescence, barely the moment when the eyes open. Yet within that tiny slice of time, there are hints of structure, luminosity, and chemistry that feel less like first breath and more like a room that is already being lived in. That does not mean the room is finished. It does not mean modern galaxies had somehow already appeared in full. The honest version is more interesting than that. These objects are still young in a deep sense. They are compact. They are likely turbulent. They're probably very different from the calm spiral forms many people picture when they hear the word galaxy. But youth does not erase the surprise. In some cases it sharpens it, because all that activity is happening inside something small. Compactness changes the emotional scale of the story. A large bright galaxy in a mature universe might feel impressive without feeling troubling. The universe has had billions of years to work on it. Time can hide almost any miracle if you give it enough room. But a compact, luminous, early system carries a different energy. It feels crowded, concentrated, ahead of schedule, less like a continent that formed over ages and more like a dense block of city lights glowing where you expected open land. You can almost feel the pressure of that. Light packed into a tiny region, mass assembling quickly, gas becoming ionized, heavy elements beginning to appear. Each one says the same thing in a different dialect. This place is not waiting around. And once you understand that, another quiet shift happens in the story. The title begins to pay off in a more serious way. The troubling questions are no longer dramatic decoration. They become specific. How did matter gather this efficiently so soon? How did stars begin and cycle so early? Were our earlier expectations too cautious about just how quickly the first galaxies could ignite? Or are there details in the light, the modelling, or the physics of early star formation that we still do not fully understand? There is a strong temptation at this point to turn everything into a grand cosmic rebellion, as if the universe has broken its own rules. But reality is usually more disciplined than that. The better way to hear the tension is this. The rules may be the same, while the first few moves of the game were more aggressive than many of us thought. That distinction matters. It keeps wonder clean. One of the most revealing clues comes from the kinds of emission astronomers have teased out of these ancient systems. Without dragging us into the weeds, certain lines in the spectrum can tell us about ionized gas, about the presence of specific elements, about the energy of the environment producing the light. In one especially important early galaxy, observations point toward oxygen in an ionized state. That might sound like an obscure technical detail, but physically it means we're not just looking at some vague ancient smudge. We are looking at gas in a highly energized setting, one that has already been shaped by luminous stars and by chemical processing that should take prior generations to achieve. Again, the fireplace image helps. You enter expecting wood that has only just been stacked, and you find ash, not heaps of it, not the remains of a long winter, but enough to prove that fire has already been there. There is another layer to this, and it is even more interesting because it does not give us a neat, tidy picture. Follow-up observations at longer wavelengths have added texture to the mystery. In one case, astronomers detected a glow associated with ionized oxygen, while another signal they might have expected from cooler or differently conditioned gas was notably absent. That mismatch does not hand us a complete explanation, but it does tell us the environment may be unusual, strongly ionized, maybe harsher than the simplest comparison to nearby galaxies would suggest. That is the kind of detail that changes the mood without needing to shout. We're not merely being told that these galaxies existed. We're being shown that some of them may have had internal conditions already shaped by intense radiation and rapid evolution. In other words, the surprise is not just presence, it is character. And character matters because it widens the implication beyond one object. A single outlier can always tempt us into caution. Perhaps it is rare. Perhaps it is unusual in a way that teaches us little about the broader population. But Webb's growing view has made it harder to hide behind that comfort. More very bright galaxies have shown up in the first billion years than many pre-Webb expectations would have made emotionally easy. The exact counts and theoretical tensions depend on the analysis, and astronomers are still working through them carefully. Even so, the broad feeling remains. The nursery did not contain just one unexpected light. There may be several. That changes the burden of explanation. Imagine walking outside in late winter and finding a single early flower blooming through frost. You would notice it, perhaps even admire it, but you could still tell yourself it was a lucky exception. Then imagine turning the corner and seeing a whole patch of colour. Suddenly it is not about one brave flower anymore. Suddenly the season itself may be arriving differently than you thought. That is much closer to the emotional truth of this moment in astronomy. Webb has not simply delivered one impossible little spark from the edge of time. It has started to sketch a population, a broader suggestion that cosmic dawn may have been more populous, more luminous, and more productive than the old mental picture allowed. This is where our intuition usually tries to retreat into vagueness. Ancient galaxy, early stars, big mystery. But staying precise gives the wonder more weight. If there are more bright galaxies than expected at those ages, then the machinery that turns primordial matter into stellar light may have been highly efficient very early on. Dark matter halos may have gathered gas rapidly. Cooling may have proceeded effectively. Star formation may have become intense in pockets sooner than many models treated as typical. None of those phrases needs to become a textbook chapter. All we really need to feel is their combined direction. The universe may have become busy early. Busy and perhaps transformative. Because brightness and chemistry do not exist in isolation. These earliest galaxies lived inside a larger environment, and that environment was not fully transparent yet. The young cosmos was filled with neutral hydrogen, and neutral hydrogen is not friendly to all light. Certain wavelengths, especially those tied to hydrogen emission from galaxies, should have had a hard time escaping into intergalactic space if the surrounding medium remained mostly neutral. It would be like trying to shine a beam through dense sea fog. The source could be real, but the world between you and it would swallow much of the signal. Which means that if we begin seeing signs of that light getting out anyway, the question becomes even more unsettling. Not just what is happening inside these galaxies, but what they may already be doing to the space around them. To understand why that matters, it helps to picture not empty darkness, but a room still filled with smoke. You can switch on a lamp in that room and still fail to see across it clearly. The light is there, but the medium fights it. Now imagine that same lamp growing stronger, hot enough not merely to glow inside the smoke, but to begin clearing a pocket around itself. The room is still full of haze overall, yet near the source, visibility starts to open. That image begins to carry us toward one of the most quietly remarkable observations in this story. Because one early galaxy, seen from only a little later than these most distant frontier objects, appears to show bright hydrogen emission that should have been much harder to witness if the surrounding universe was still uniformly fogged with neutral gas. And that means the fog itself may already have been breaking, at least locally, much sooner than feels comfortable. Sooner than comfortable is a strange kind of phrase to apply to the universe, but it captures something real about how we process this. Not fear, exactly, more like a quiet resistance. We prefer beginnings that give us time to settle in, to understand the rules before anything too complex happens. And yet here, the story seems to unfold in a way that compresses that gentle introduction into something more immediate. Because if a galaxy that early is already producing light that can escape, at least in part, through a medium that should still be difficult to cross, then we're no longer just looking at isolated islands of stars. We are looking at systems that may already be shaping their surroundings, not globally, not all at once, but locally, carving out small regions of clarity inside a much larger haze. That is the next layer of the problem. Not only did these galaxies appear early, not only did some of them become bright quickly, not only do they show hints of chemical activity, but they may also already be interacting with the wider environment in a way that changes how light travels. It becomes harder and harder to imagine this era as quiet. And this is where our intuition begins to fail in a more subtle way. When we hear that the universe was only a few 100 million years old, we instinctively translate that into something like infancy. We expect fragility. We expect incompleteness. But the universe does not measure itself in human metaphors. A few 100 million years is an enormous amount of time for physical processes that are not waiting for anything. Gravity does not hesitate. Gas does not pause to consider. Once the conditions are right, matter moves, collapses, ignites. So perhaps the discomfort is not that the universe moved too quickly. Perhaps it is that our sense of what counts as early is not well calibrated to cosmic reality. Even so, the tension remains. Because our earlier models were not careless guesses. They were built from decades of observation, from simulations, from an understanding of how matter behaves under gravity, how gas cools, how stars form. They did not predict an empty beginning. They predicted a beginning that was active, but not this active, not this soon, not with this particular combination of brightness, compactness, and chemical signals. That is what gives this moment its weight. It is not that everything is wrong. It is that something important may need to be adjusted. And adjustments in science are often quiet at first. They do not arrive as declarations. They arrive as patterns that do not quite fit, as observations that refuse to sit comfortably inside the existing picture. At first, they are treated with caution. Are the measurements secure? Are there alternative explanations? Could something about the light be misleading us? Could gravitational lensing be amplifying the brightness? Could we be misinterpreting the signals in subtle ways? Those questions are still being asked, and they should be, because the more extraordinary the implication, the more careful we have to be about the path that leads there. But what gives this situation its particular character is that even after that caution, the core pattern has not simply dissolved. The distances are real, the brightness is real, the spectral signatures are real, and taken together, they continue to press in the same direction. The early universe may have been more efficient at building galaxies than we expected. Efficiency is a quiet word, but here it carries enormous weight. It suggests that the conversion of gas into stars, the assembly of mass into structures, the transformation of simple elements into more complex ones, may have proceeded with fewer delays, fewer bottlenecks, fewer pauses than many models assumed. Not infinitely fast, not magically, but faster in the only way that matters, enough to change what we should expect to see when we look back. And when expectation changes, so does interpretation. Because now, when we observe a galaxy from that deep past, we can no longer treat it as a tentative flicker at the edge of existence. We have to ask, what has already happened inside this system before its light ever began the journey toward us? How many stars have formed? How many have ended? What kind of radiation has been pouring into its surroundings? What kind of structure has already taken shape inside something that, from our perspective, belongs to the first moments of cosmic history? There is a quiet shift in language that happens here. Instead of saying we are seeing the first galaxies, it becomes more accurate and more unsettling to say we are seeing galaxies that are already in progress, very early on. Already in progress. That phrase changes the emotional texture of everything that follows, because it means that when you look at one of these objects, you are not looking at a beginning in the sense of a blank starting point. You are looking at a snapshot taken after events have already unfolded, after processes have already been running, after time, however short it feels to us, has already been spent. And this is where the story begins to widen beyond individual galaxies. If one system can reach this level of activity that early, and if others are being found that share at least some of these characteristics, then the question naturally expands. What was the broader landscape like during those first few 100 million years? Was it mostly quiet, with rare pockets of intense activity, Or was it more generally alive, with many regions forming stars, emitting light and gradually transforming the surrounding medium? The answer is still being built. That is important to say clearly. We are in the middle of a process, not at the end of it. But even in the middle, there are hints strong enough to reshape the way we imagine that era. One of the most powerful of those hints is not a single galaxy, but the sense of population. The fact that Webb has not simply found one bright object at the edge of time and then nothing else comparable. It has found multiple candidates, multiple confirmed systems, each adding weight to the idea that this was not an isolated accident. And that brings us back to something deeply human. When we look up at the night sky, it feels calm. Even when we understand that stars are burning and galaxies are moving, the overall impression is still one of quiet distance. The past feels settled. Whatever happened in those early epochs feels complete, finished, almost frozen into the light that reaches us. But this new picture makes the past feel less settled. Not chaotic in a dramatic sense, but active in a way that compresses the timeline. The early universe was not simply waiting to become interesting. It may have become interesting very quickly, and that quickness is what we are now beginning to perceive. You can feel the difference if you imagine watching a recording. At first, you think you're about to see the very beginning of something, a slow fade in, the first tentative movements. Instead, the video starts and within moments there is already motion, already interaction, already signs that something has been happening just before the recording began. You missed the true beginning. You arrived just after it, and everything is already underway. That is what these galaxies are starting to feel like. And that realization leads to a deeper question that is harder to hold on to, but more rewarding if you stay with it. If the early universe was already active, already forming structures, already generating light and chemical complexity sooner than expected, then how should we adjust our mental picture of cosmic history as a whole? Not in terms of rewriting everything, but in terms of timing, in terms of pacing. Because history is not only about what happens, it is about when it happens, and when shifts, even slightly, can ripple outward into many different areas of understanding. It affects how we model the growth of structure. It affects how we think about the transition from a neutral universe to one filled with ionized gas. It affects how we interpret the faintest light we can detect. It even affects how we place ourselves within the story, because it subtly changes the distance between then and now. And that distance is already immense, which makes the next step even more remarkable, because even as we are trying to absorb these results, the observational frontier is still moving. The most distant confirmed galaxy is not a fixed endpoint. It is a marker that keeps shifting as new data comes in, as new candidates are identified, as spectroscopy confirms what imaging suggests. So the edge of this story is not stable. It is creeping closer to the beginning, and with each step inward, the same question waits to be asked again, with slightly more urgency. If this is what we see here, what will we see just beyond it? And that is where the sense of quiet tension returns, not as anxiety, but as anticipation. Because if galaxies at around 300 million years after the Big Bang already look this active, this luminous, this chemically suggestive, then pushing even earlier does not just extend the map, it tests the limits of our expectations. And we are only just beginning to see how far those expectations can stretch. How far those expectations can stretch is not something we answer all at once. It reveals itself slowly, through each new observation, each carefully confirmed signal, each small extension of the cosmic horizon. And what makes this moment unusual is not just that the horizon is moving, but that what we are finding near it is not behaving in the most comfortable way. Because if you step back for a moment, the tension we are feeling is really about timing layered on top of structure. We are not surprised that galaxies exist. We are not surprised that stars form, that light is produced, that heavier elements eventually appear. All of that belongs to the basic story of the universe. What is under quiet revision is how compressed that story might be in its earliest chapters. And compression changes everything. Imagine reading a long novel where the first few chapters were expected to be slow, careful, introductory. You expect characters to be sketched lightly, conflicts to be hinted at, the world to be established piece by piece. Instead, you open the book and within a handful of pages, relationships are already tangled, events are already unfolding, and the world feels lived in before you have had time to settle into it. That is the sensation Webb is starting to create. Not chaos, not contradiction, but acceleration. To understand why that matters so much, we need to stay with one more piece of the physical picture, something that connects all these threads together: the state of the space between galaxies at that time. It is easy to imagine space as empty, but in the early universe, it was anything but simple emptiness. It was filled with hydrogen gas, and for a long period after the first atoms formed, that hydrogen remained mostly neutral. Neutral hydrogen has a very particular effect on light. It can absorb or scatter certain wavelengths, especially those associated with hydrogen emission from galaxies themselves. In practical terms, that means the early universe should have behaved like a kind of fog, not an impenetrable wall, but a medium that makes it difficult for specific kinds of light to travel freely across large distances. This period is sometimes described as a kind of cosmic dawn, followed by a gradual clearing. As the first stars and galaxies formed, their radiation began to ionize the surrounding hydrogen, stripping electrons from atoms and changing how light could move through space. Over time, these ionized regions grew, overlapped, and eventually transformed the universe into a state that is largely transparent to that light. But here is where the timing becomes crucial. If you go far enough back, you expect most of that fog to still be in place. The clearing should be incomplete. The universe should still be, in a broad sense, murky. So when we detect signs of certain kinds of light escaping from galaxies at very early times, it creates a specific kind of question, not a vague one, a physical one. How did that light get out? There are a few ways to think about it, and none of them require abandoning what we know. One possibility is that the galaxies themselves are producing enough intense radiation to carve out local regions of ionized gas around them, like clearings in a forest. Within those clearings, light can travel more freely before encountering the denser neutral medium beyond. Another possibility is that the structure of the surrounding gas is not uniform. Instead of a smooth fog, it might be clumpy, with channels or lower density regions that allow light to leak through more easily than a simple picture would suggest. These are not speculative in the sense of being ungrounded. They are part of the active effort to reconcile observation with theory. But what matters for us is not choosing one explanation over another. It is feeling what the need for these explanations implies. It implies that galaxies at these early times may already be powerful enough to influence their environment in measurable ways. That is a different kind of presence than a quiet, newly formed object. And when you layer that onto everything else, the brightness, the compactness, the hints of chemical enrichment, you begin to see the outline of a consistent picture. These early galaxies are not passive. They are active systems, already engaged in shaping the universe around them. That is where the word troubling in the title finds its most honest meaning. Not troubling in the sense of danger, not troubling in the sense of something gone wrong, but troubling in the sense that it unsettles a simple narrative. It refuses to let the early universe remain a distant, quiet prologue. It insists on being a place where significant things were already happening, perhaps faster than we had comfortably imagined. And this brings us to another subtle shift in perspective. When we think about the history of the universe, we often imagine it as a smooth unfolding, with each stage clearly separated from the next. First the hot early state, then the formation of atoms, then the first stars, then galaxies, then larger structures, each step neatly following the previous one. But reality rarely respects our desire for clean boundaries. Processes overlap, transitions blur. The first stars may still be forming even as the first galaxies begin to assemble. Ionized regions may appear in pockets even while most of the universe remains neutral. Chemical enrichment may begin in some regions while others remain pristine. What Webb is showing us is not that the sequence is wrong, but that the overlap may be more intense, more intertwined, more compressed than we once pictured. Everything is happening closer together in time. And when everything is closer together, the early universe stops feeling like a set of distinct phases and starts feeling like a dense period of simultaneous activity. If you imagine standing inside that era, not as a physical possibility, but as a mental exercise, it would not feel like watching one event at a time. It would feel like being surrounded by processes unfolding at once, light igniting, gas collapsing, regions clearing, elements forming, all within a relatively short span, at least by cosmic standards. That is a very different emotional landscape. It is also one that helps explain why these observations matter beyond the specifics of any single galaxy. Because what we are really probing is not just the existence of objects, but the tempo of the universe itself. Tempo is not something we usually talk about in physics, but it is deeply embedded in everything we observe. How quickly do structures form? How rapidly does energy flow? How soon do environments change? These are questions about pace, and Webb is quietly suggesting that the early tempo may have been faster. Not infinitely fast, not beyond the laws of physics, but faster in the sense that more happened sooner than our earlier mental picture emphasized. This does not collapse the story, it sharpens it. Because now, instead of imagining a long, gentle ramp-up to complexity, we're invited to consider a beginning that became dynamic almost immediately, a universe that did not linger in simplicity for very long before beginning to build. That idea carries a strange kind of calm intensity. It does not shout, it does not need to, it simply sits there, changing how the entire timeline feels. And as that feeling settles in, another realization begins to emerge, one that connects all of this back to us in a way that is easy to miss if we stay only with the technical details. Everything we're discussing, the light, the galaxies, the chemistry, the ionization, has been travelling toward us for most of the age of the universe. The signals we're now interpreting began their journey long before the Earth existed, long before the sun formed, long before any human mind was here to wonder about them. And yet, here we are, able to receive that light, to decode it, to notice that something about it does not fit our expectations as neatly as we thought. There is something quietly extraordinary about that, because it means that the early universe is not just something that happened and ended. It is something that is still, in a sense, arriving. Each photon carries a fragment of that early activity across billions of years of expanding space, and when it reaches us, it completes a connection that spans almost the entire history of the cosmos. You can feel that if you slow down enough. You're not just looking at something far away. You're participating in a chain of events that began when the universe itself was very young. The light left that galaxy when it was already active, already evolving, already shaping its surroundings. And now, after all that time, it reaches a small planet orbiting an ordinary star, where a species has developed the tools to notice that the timeline might be tighter than it once believed. That is where the story becomes both larger and more intimate at the same time. Larger because it stretches across billions of years, more intimate because it ends here, in perception. And that is why the next question matters so much. If the early universe was already this active, already forming structures, already generating light and complexity, then what does that say about the very first moments of galaxy formation themselves? Not the ones we can currently see, but the ones just beyond our reach, where the light is even more stretched, even more difficult to detect. Because just beyond this frontier, the same pattern may continue, or it may change. And we are very close to finding out. Very close, in cosmic terms, does not mean close in any ordinary sense. It means close to the edge of what our instruments can currently pull out of the dark. Close to the point where ancient light has been stretched so far by the expansion of space that it arrives not as the kind of glow human eyes evolved to notice, but as a whisper in infrared. Close to the era where the difference between one model of the early universe and another can hide inside the faintest details of a spectrum. That is why Webb matters so much here. It was not built simply to take prettier pictures than the telescopes before it. It was built to reach into that stretched, reddened frontier and bring back evidence from a time when the universe was still young enough to surprise us in foundational ways. And what makes its discoveries emotionally powerful is that they do not feel like decorative discoveries. They feel consequential. They change how the opening pages of reality read. To understand that, it helps to pause and consider what a galaxy actually is in this context. Not a serene spiral turning in isolation, like the familiar images on posters and screensavers. At these early epochs, a galaxy is more like a dense event, a concentration of matter where gravity has gathered gas. Stars are igniting at a furious pace, radiation is reshaping the environment, and history is being written quickly. The word galaxy can make the scene sound mature and settled. In these first hundreds of millions of years, it may be better to think of them as fierce young structures, still forming even as they shine. That is why size can be misleading. Some of these early systems are physically small compared with giant modern galaxies, yet that smallness is part of the shock. The light is coming from a region that can be surprisingly compact. The activity is concentrated. If you try to visualize it, it is not like an entire continent glowing softly. It is more like discovering that a whole district of intense industry has been packed into a few city blocks. And when light pours out of a compact region like that, the question changes shape. We're no longer asking only whether structure exists. We're asking how hard the engine is already running. That engine is powered by stars, and stars are not passive markers on a timeline. They are factories of transformation. They collapse from gas, ignite nuclear fusion, flood their surroundings with radiation, and in their deaths or wins they alter the chemistry of the space around them. So when Webb sees signs that a very early galaxy is bright, ionized, and chemically active, it is not merely seeing a thing. It is seeing a process that has already burned through some of its own future faster than expected. That phrasing matters, burned through some of its own future. Because from our point of view, these galaxies are so early that we instinctively assign them a kind of innocence. We expect them to be near the start of their story. But the evidence suggests that even by the time their light begins the journey to us, they may already be past the simplest version of a beginning. They have already formed stars. Some of those stars may already have lived and died. Their surroundings may already have been changed by the energy released within them. The first chapter, in other words, may already contain several chapters worth of action. Now, that does not mean every early galaxy must look the same. This is another place where it helps to remain grounded. The universe is not a factory producing identical outcomes. Even today, galaxies vary enormously in size, shape, brightness, composition, and environment. There is no reason to expect the earlier systems to be uniform. Some may have formed stars more intensely than others. Some may sit in regions where matter gathered faster. Some may clear their surroundings more efficiently. Some may remain faint and elusive. But the existence of variation does not dissolve the tension. It sharpens it. Because if some of the earliest galaxies are already this active, then the range of possibilities in the early universe may be wider than the older, simpler picture allowed. A wider range means a more textured dawn. And textured dawn is a useful phrase, because it captures what is replacing the old smoothness. We used to talk about cosmic dawn as if it were one clean event, a gentle brightening of the universe as the first stars and galaxies turned on. What Webb is helping reveal is something more uneven and alive. Not one uniform sunrise, but scattered lights, local clearings, dense pockets of formation, regions ahead of others, a universe waking up in different places at different rates. If you have ever watched a large city from above before sunrise, you know that the darkness does not leave all at once. Some streets glow earlier, industrial areas stir before residential ones, a few windows light up, then blocks, then neighborhoods. The whole place is still night, but pieces of morning have already begun. That may be much closer to what the first great brightening of the universe was like. And if it was, then the troubling questions raised by Webb are not about a single oddball galaxy at all. They are about the texture of emergence itself. How patchy was it? How quickly did some regions race ahead? How soon did enough stars exist to begin changing the transparency of space? How early did chemical complexity start to spread into the gas from which later generations of stars would form? These are questions about a living timeline, not a static one. They are also questions that point toward one of the deepest themes in modern astronomy. The universe is often more local, more uneven, and more physically specific than our broad summaries make it sound. We say, the universe was neutral, but that can hide the fact that some regions may already have been ionized. We say the first galaxies were forming, but that can hide the fact that some may have been far more luminous than others. We say chemical enrichment began later, but that can hide the fact that in some compact systems, the cycle may already have been underway much sooner. Broad statements are useful. Reality lives in the details. And Webb was built for details, not merely for reach, but for character, for the ability to distinguish one kind of ancient light from another, to separate a mere distant candidate from a securely measured object, to read not only that something existed, but hints of what it was like. That is how a galaxy becomes a problem worth taking seriously. If all we had were fuzzy dots at the edge of visibility, the imagination would run ahead of the evidence. But when the distance is secured through spectroscopy, when the luminosity remains, when the signs of ionized gas and early enrichment begin to appear, the story becomes much harder to dismiss. Then you have to sit with it. You have to let the scale of the claim work on you slowly. This galaxy was already shining fiercely less than 300 million years after the Big Bang. Another confirmed object reaches back to about 280 million years after the beginning. Those are not just records, they are pressures on the calendar. And the calendar is what makes the whole thing feel intimate in a strange way. Humans are very good at feeling differences inside small spans of time. A day can feel long, a month can feel transformative, a decade can remake a life. But we are very bad at feeling the difference between 280 million and 330 million years in a universe 13.8 billion years old. Both just sound ancient beyond repair. Both sound equally remote. Yet in the early universe, that gap matters. Those tens of millions of years are not decorative. They are developmental time. They are the difference between having more or less opportunity for stars to form, for radiation to build, for gas to be altered, for local bubbles of ionized space to grow. When you're standing so close to the beginning, every increment matters more. It is like the first minutes after sunrise in a foggy harbour. 5 minutes may not mean much at noon. At dawn, 5 minutes can completely change what you can see. One outline becomes 10. One reflection becomes a line of water. A vague glow becomes a visible ship. That is what we are dealing with at these redshifts. Not just distance, but timing in its most compressed and unforgiving form. Which is why each new object found near this frontier matters beyond its own existence. Each one is another data point in the narrowest and earliest slice of history we can currently access. Each one helps answer whether the systems already known are rare exceptions or members of a broader class. Each one helps refine the tempo. And the tempo keeps feeling quick. Even the caution around this is revealing. Astronomers are careful because they have to be. They examine whether the brightness could be affected by measurement uncertainties, whether line identifications are secure, whether theoretical assumptions about stellar populations should be adjusted, whether more exotic ingredients are necessary, or whether ordinary physics under early conditions can account for what is seen. But underneath that careful work, the same calm fact remains. Something important is happening very early. Not eventually, early. That word carries most of the emotional weight in this story. Early stars, early galaxies, early enrichment, early clearing of the fog, early structure, early intensity. Too many things arriving early is what creates the troubling feeling. And if that feeling grows stronger the farther inward Webb pushes, then the next frontier will not just be about beating a record. It will be about finding out whether this accelerated opening is an isolated feature of a few systems, or part of the universe's deeper personality. Because just beyond the objects we have already secured is an era even closer to the beginning, where the first sustained bursts of galactic activity may be waiting in light that is only now reaching us. Only now reaching us, after a journey so long that every familiar measure of time becomes useless. No dynasty, no language, no species memory is deep enough to hold it naturally. The light left when the universe was still in its opening stretch, crossed expanding space for more than 13 billion years, slipped past eras in which stars were born and died, galaxies collided, the sun formed, the earth cooled, life emerged, and eventually a primate species learned how to polish mirrors, cool detectors, and ask whether the beginning was busier than it looked. That is the scale we're working inside. And once you feel that, another shift becomes possible. These observations stop feeling like isolated astronomy news and start feeling like a confrontation with how reality keeps resisting our instinct for simplicity. We want the beginning to be clean. We want the first few 100 million years to sit quietly in their corner of time, primitive and sparse and easy to narrate. Instead, the evidence keeps suggesting that the opening was already full of local urgency. Matter was gathering. Stars were igniting. Radiation was pushing outward. Chemistry was beginning to diversify. The universe may have become complicated very fast. That sentence is stronger than it sounds. Because complication is expensive. It demands cycles. It demands structure. It demands energy flowing through systems, changing them. A chemically simple gas can remain simple for a while. A chemically enriched, luminous, compact galaxy requires more from history. Not infinite history, but enough. Enough prior star formation, enough intensity, enough time spent doing real physical work. This is why the story keeps returning to clocks. Brightness is a clock. Chemical enrichment is a clock. Ionized gas is a clock. Even the absence of certain signals where we might have expected them can become a clock, because it tells us something about the state of the gas and the radiation environment. Every one of these clues asks the same question in a different voice. How much had already happened by then? And if the honest answer keeps coming back as more than expected, then cosmic dawn becomes less like a gentle gradient and more like a compressed surge. A surge is not the same as chaos. It is just a lot of consequential things happening in a relatively short span. We know this feeling from ordinary life. There are years that seem broad and quiet, and there are months in which an entire life seems to reorganize itself. The laws of time have not changed, but the density of events inside time has. Webb is inviting us to think about the first chapter of the universe in that second way. The duration is still immense by human standards, yet the density of change may have been unusually high. That idea becomes even more interesting when we remember that galaxies do not form in isolation from the underlying structure of the universe. Long before stars shine, matter is already beginning to gather under gravity. Dark matter, though invisible, helps create gravitational wells. Gas falls inward. Density differences matter. Some regions start with slight advantages, and those advantages can compound. The universe does not unfold as a perfectly even field. It unfolds with texture, with gradients, with places where gravity gets there first. That may be part of what we're seeing. Not a universe breaking its own rules, but a universe using them efficiently in some of its earliest, densest regions. If so, that helps explain why the story is both surprising and disciplined at the same time. Surprising because the old mental picture was too smooth. Disciplined because nothing about this requires magic. Gravity still behaves like gravity. Gas still cools according to physical laws. Stars still form from collapsing clouds. Radiation still ionizes surrounding material. The remarkable thing may simply be that these ingredients were able to combine into luminous, compact systems earlier and more effectively than many people had pictured before Webb had the data to force the issue. There is something almost relieving in that. Reality is stranger than we assumed, but not arbitrary. And still, the emotional force remains, because once you start seeing the early universe this way, everything behind the title grows heavier. So far away now means so early that even modest signs of maturity become loaded. A distant galaxy is no longer just a trophy at the edge of detection. It becomes testimony, evidence that the first few 100 million years contained more action than the simpler story suggested. That is why even a careful phrase like larger than expected population of luminous galaxies carries such weight. It sounds technical, almost dry, but if you translate it into feeling, it means this may not be one improbable candle in a vast dark room. It may be a room where more lights were already on than expected. That changes the room. It also changes how we imagine darkness itself. The ancient universe is often spoken of as though it were blank until the first stars switched on. But blankness is not really the right word. The stage was already set by matter distribution, by cooling, by collapsing gas, by the potential for starlight. And once the first sources ignited, darkness did not vanish all at once. It thinned unevenly. It became porous. It developed bright pockets, local clearings, intense compact systems sending radiation into a medium that was still, on the largest scales, far from transparent. That is a very different kind of darkness from the one most of us picture. It is not passive, it is under pressure. If you have ever stood on a coastline before sunrise, you know the feeling. The world is still dark enough to be called night, yet the darkness is no longer stable. The horizon has begun to leak. The outlines of waves come and go. A distant light on a boat suddenly reaches farther than it did a few minutes earlier. Nothing has fully changed, but everything is already changing. That is a better emotional model for cosmic dawn than a simple switch from off to on. And once we allow ourselves to feel that, the observations make more sense as a connected story. Bright early galaxies are not just curiosities, they are signs of pressure building inside the darkness. Spectral hints of ionized gas are not just technical details. They are evidence that the darkness was being worked on from within, metal enrichment is not a decorative flourish. It is proof that stellar life cycles had already begun to alter the ingredients. The beginning was not empty, it was becoming. That line matters because it protects us from two opposite mistakes. One is to imagine the early universe as static and uneventful. The other is to treat every surprising observation as a crisis. The stronger view is between those extremes. The beginning was dynamic, and our newer observations are helping us see just how dynamic. That may require revising assumptions about pace, efficiency, and local variation. But revision is not collapse. It is refinement under pressure from better evidence. In some ways, that is more beautiful than a dramatic overthrow. It means the universe is teachable in the deep sense. It keeps offering details that force us to sharpen our picture without tearing up the whole canvas. And sharpening the picture is exactly what these frontier galaxies do. Take the issue of abundance. One distant bright galaxy can be told as a special case. A second can be framed as luck. A third, a fourth. A growing sample of luminous systems in the first billion years starts to feel like a broader statement. Not a final one. Samples are still small. Selection effects matter. Confirmation takes care and time. But the emotional direction is no longer easy to ignore. The old expectation of how sparse and faint this era would be has been weakened. What replaces it is not certainty, but a new posture of attention. We have to be ready for an early universe that is more populated in light than expected, more chemically advanced in pockets, more structurally active, and more capable of shaping its own transparency. Each phrase carries its own scientific nuance. Together, they say something simple. The first great illumination of the cosmos may have had more force to it than our Karma sketches implied. If that is true, then we're not just adjusting a set of models, we're adjusting the mood of the beginning. That may sound like a poetic way to put it, but it is actually quite precise. In science, mood often hides inside expectation. Do we imagine slow build-up or rapid onset, sparse exceptions or emerging populations, uniformity or patchiness, a long, quiet preface or a crowded opening paragraph? Webb is not giving us a final answer to all of those choices, but it is steadily shifting the emotional balance toward the second option in each pair. And this matters because mood shapes comprehension. If you imagine the early universe as mostly empty waiting room space, the discoveries feel bizarre. If you imagine it as a physically intense era where gravity, gas, and radiation quickly began building local complexity, the same discoveries still feel remarkable, but they stop feeling disconnected. They become part of a coherent, if newly sharpened, picture. Still, coherence is not the same as comfort. There remains something quietly unsettling about the thought that by roughly 280 to 300 million years after the Big Bang, some galaxies were already bright enough, already active enough, and perhaps already influential enough to force this conversation. That span of time is immense to us, but close enough to the beginning that every sign of maturity lands with unusual weight. It is like finding deep footprints not far from a shoreline you thought had only just begun to dry. And the closer the frontier moves, the heavier those footprints become. Because each new step inward cuts away some of the available time. Each earlier confirmation narrows the window in which stars had to form, gas had to gather, radiation had to intensify, and the surrounding medium had to begin responding. The objects do not merely get older in distance, they get more demanding in implication. That is why the next frontier is so compelling, not because records are exciting in themselves, but because every earlier galaxy asks a harsher version of the same question. How quickly can the universe become luminous, structured, and chemically alive once the first conditions are in place? We are still measuring the answer, but the answer already seems to be quicker than we once found comfortable. Quicker than we once found comfortable. And that discomfort is useful because it forces us to notice how often our intuition quietly confuses age with simplicity. We assume that if something belongs to the early universe, it must also belong to an uncomplicated universe. But age and simplicity are not the same thing. A system can be young and still intense. A process can begin recently and still be moving with tremendous force. You can feel that in ordinary life. A storm can build in an afternoon. A city block can transform in a year. A forest can burn and regrow on timescales that feel sudden to the land living through them. None of those examples is truly comparable to cosmic history, but they help correct the emotional error. Beginnings are not always slow. Sometimes beginnings are where the fastest changes happen. That may be especially true when the basic ingredients are already in place. Gravity does not need to be taught how to gather matter. Hydrogen does not need encouragement to collapse under the right conditions. Radiation does not need permission to flood outward once stars ignite. The laws of physics are efficient, and if the earliest dense regions of the universe gave them enough to work with, then perhaps what we are seeing is not an impossible acceleration, but the natural outcome of those laws acting with more early efficiency than our older expectations emphasized. And yet that still leaves the emotionally important fact untouched. We did not expect this exact picture, not this combination, not galaxies this early that are bright enough to matter, compact enough to feel concentrated, and chemically suggestive enough to imply prior stellar generations. That combination is what gives the story its shape. One clue on its own is interesting. Several clues pointing the same way begin to feel like character evidence. The character emerging here is of a cosmos that reached visible complexity early, not complete complexity, not the calm layered richness of the later universe, but enough complexity to make the opening stretch feel crowded, enough to suggest that by the time the light we now detect left those galaxies, significant internal work had already been done. There is a simple way to feel that without getting lost in terminology. Imagine arriving at what you think is the start of a construction project. You expect cleared ground, maybe some marked lines, maybe a few machines just arriving. Instead, there are already walls, already power, already workers inside. The building is nowhere near finished, but it is unmistakably underway. That is the emotional correction Webb keeps asking us to make. The early universe was not just beginning. In places, it was already underway. This is also why the issue of stellar mass matters so much, even though it can sound dry on first hearing. Saying that a galaxy may already contain hundreds of millions of solar masses in stars is not just bookkeeping. It means that a substantial amount of gas had already been turned into luminous structure. In a period where we once pictured many galaxies as tiny and faint, that becomes a statement about pace. The material was gathered, the stars formed, the light switched on. That is a lot to ask from a young universe, and still it seems to have happened. Of course, a lot depends on the frame. By human standards, 100 million years is beyond vast. It is longer than the existence of our species by an absurd margin. If all of human history were laid out in front of us, it would barely scratch the surface of such a span. But against the full age of the universe, and especially against the first few 100 million years when everything was still near the beginning, that span becomes precious. It is developmental time. It is time under pressure. So these observations force us to think in a split perspective. Humanly, the early universe had plenty of time to do all sorts of things. Cosmically, some of these galaxies are appearing at moments so close to the beginning that even modest signs of maturity carry unusual weight. Both are true at once, and the tension between them is part of what makes the story so absorbing. We are being asked to feel time at two scales simultaneously. At our scale, the universe is unimaginably old. At the scale of cosmic dawn, a few tens of millions of years can transform the interpretation of what we are seeing. That is why the frontier moving from one confirmed galaxy to another matters so much. A shift from around 330 million years after the Big Bang to around 290, or from around 290 to around 280, is not just a numerically smaller record. It tightens the available window. It reduces the room in which stars could form, enrich gas, and alter the surrounding medium. The closer we move inward, the less slack there is. And slack is what earlier models often quietly relied on. Not because they were weak, but because before Webb, the evidence simply did not push as hard on those earliest times. There were models, simulations, inferences, expectations. There was a picture, and it was grounded. But the observational pressure from the first few 100 million years was limited. Webb changed that by opening the infrared window wide enough to let the distant past start answering back in detail. Now the answers are arriving. They are not simple answers. They do not come in one sentence. They come as spectra, as luminosity functions, as compact morphologies, as line detections and line absences, as strange combinations that resist a neat summary. But the emotional direction is clear enough to feel. The beginning may have had sharper edges, brighter pockets, and more local intensity than many of us had been carrying in our minds. This is where the difference between observation and interpretation becomes worth holding on to carefully. Observation says these galaxies are there, at these redshifts, with these luminosities, with these spectral hints. Interpretation asks why. Are the stars unusually efficient at producing light? Are the stellar populations different from what we assumed? Are the conditions inside these galaxies allowing rapid mass assembly? Are we seeing local environmental effects that help explain the escape of certain photons? Those are active questions. The important thing is that uncertainty here does not weaken the story. It deepens it. Because the uncertainty is not about whether the light exists. It is about what physical combination produced it so soon. That is a much stronger kind of mystery than simple doubt. It means the universe has already given us the fact, and now we're trying to understand the machinery. And the machinery may turn out to be more vigorous in those early conditions than older expectations suggested. This possibility has a subtle emotional consequence. It makes the first few 100 million years feel less like a distant museum exhibit and more like a threshold of intense physical labour. Gas is falling inward. Stars are turning on. Radiation is pouring through narrow, changing environments. Heavy elements are starting to seed the surroundings. Local bubbles of transparency may be opening inside a wider opaque medium. None of this is cinematic decoration. It is simply what the evidence begins to imply when translated back into physical terms. You can almost hear the silence differently after that. Not literal sound, of course, but the silence of the night sky as we experience it now. We tend to project that stillness backward, imagining the early cosmos as some even quieter version of what we see overhead. In truth, the calm of the sky is deceptive. It is the calm of distance, not inactivity. Those ancient photons reaching Webb carry the memory of regions that may have been deeply busy even while the larger universe still looked dark and unfinished. That is one reason the story stays with people. It changes the emotional meaning of darkness. Darkness no longer means absence. It can mean distance, or neutrality, or a medium not yet fully cleared, while within it intense events are already underway. A dark room can contain a furnace. A foggy harbour can hide moving ships. A young universe can hold galaxies that are already changing the conditions around them. And once you start seeing things that way, the troubling questions stop feeling like technical footnotes. They begin to feel almost inevitable. If galaxies were already this active, how many were there? If some were already chemically enriched, how quickly did the first stellar generations live and die? If certain emission escaped surprisingly early, how patchy was the clearing of the cosmic fog? If compact systems were producing so much light, what does that say about star formation in the densest regions of cosmic dawn? Each question opens into another, and yet the narrative remains calm because all of them point back to the same central realization. The early universe may have matured locally faster than the old smooth picture allowed. That is the heart of the matter. That is why this is not just a story about distance. It is a story about tempo, about compression, about the burden placed on a timeline when too many signs of activity appear too soon for comfort. Which brings us to something even more interesting than the galaxies themselves. Because once the timeline becomes the real subject, Webb is no longer merely showing us objects. It is showing us pressure on the history of the universe, pressure on when the first substantial structures assembled, pressure on when enough stars existed to enrich gas, pressure on when local ionized regions could begin to open, pressure on how quickly the earliest chapter moved from potential to action. And pressure on history is a very different kind of discovery than a beautiful image. It does not only ask us to look, it asks us to reconsider the pacing of everything that came after. That is why the frontier keeps drawing us forward. Each earlier galaxy is not just another point in space, it is another argument about the first few pages of the cosmic story, and the arguments are beginning to sound less cautious, less empty, more crowded with activity than we once imagined. More crowded with activity than we once imagined, and that phrase is doing more work than it first appears to. Because a crowded beginning is not merely an aesthetic revision. It changes the internal logic of the early universe. It means that by the time we arrive with our telescopes, even at what feels like the edge of time, we may already be arriving late to events that had started gathering momentum before the light ever left. That is a subtle but profound shift. We often talk as if seeing farther means seeing closer to the beginning in a pure sense, as though we are peeling reality back to its first untouched layer. But telescopes do not show untouched layers. They show moments, and a moment, even a very early one, can already contain consequences. A galaxy at around 280 or 290 million years after the Big Bang is not the first instant of galaxy formation. It is a snapshot taken after some amount of build-up has already happened. The fact that the snapshot already contains so much activity is exactly what makes it so revealing. It tells us that the hidden lead-up may have been intense. You can think of it like stepping into a theatre just after the curtain rises and realizing the actors are already in motion, already mid-gesture, already speaking with the force of a scene that has been building. You did not witness the setup directly, but you can feel from the state of the room that the setup must have been swift and consequential. That is what these frontier galaxies are doing to our sense of cosmic history. They are not simply showing us the past. They are showing us a past that may already be farther along than expected. And once that lands, another important distinction becomes easier to hold. The troubling aspect of these discoveries is not that the universe is more dramatic than we hoped. It is that the universe may be more efficient, more physically productive in short spans, better at assembling light, stars, and structure early on than the older emotional picture allowed. Efficiency can sound bloodless until you translate it. Imagine expecting the first workers to arrive at sunrise and finding that half the building frame is already standing. Not completed, not polished, but undeniably advanced. The shock does not come from impossibility. It comes from the amount of work already accomplished in the time available. That is what makes these galaxies feel ahead of schedule. This sense of schedule is why the frontier keeps getting more interesting rather than less. In many kinds of discovery, once the record is broken once, each new record can feel like a smaller echo of the same thing. That is not how it works here. Every step inward compounds the problem. Each earlier confirmation steals time from the systems we're observing. Each earlier luminous galaxy narrows the window in which matter had to gather. Stars had to ignite. Radiation had to intensify, and local environments had to change. So the significance grows as the time shrinks. That is why a galaxy observed at around 280 million years after the Big Bang does not merely beat one seen at around 290 or 330 million years. It changes the pressure on the clock. It asks whether the physical processes we're invoking can operate quickly enough under early conditions to produce what is seen. Sometimes the answer may be yes, with modest adjustments. Sometimes it may demand more substantial refinement in our assumptions about stellar populations, star formation efficiency, or the abundance of luminous systems. But in every case, the burden is heavier. And that burden is what makes this more than a record race. It becomes easier to feel that if we stay with the chemistry for a little longer. Heavy elements are not part of the universe in the same way the lightest ingredients are. They are manufactured. They require stars. They require furnaces hot enough to build more complex nuclei. And then some route for that processed material to return to the gas from which later stars may form. So even cautious evidence of early metal enrichment carries enormous narrative weight. It means that the galaxy we are seeing is not just lit up. It may already contain the aftermath of previous stellar lives. Again, the fireplace image is hard to improve on. You think you're arriving at the first spark, and instead you find traces of earlier burning. What's especially striking is that this does not have to imply ancientness in the ordinary sense. A massive star can live fast and die relatively quickly, far faster than a star like the Sun. Under the right conditions, the universe does not need billions of years to begin this cycle. It only needs enough time, and in those first few 100 million years, enough time may already have existed in some regions. That is the quiet correction Webb is helping us make. Early does not mean too early for anything meaningful to have happened. It means early enough that every meaningful thing that has happened becomes more consequential. That makes the observations emotionally dense. Brightness means stars. Compact brightness means intense star-forming activity in a small region. Ionized oxygen suggests energetic conditions and prior enrichment. The apparent absence of cooler gas traces in some follow-up work hints that these environments may not resemble the gentler, more familiar gas conditions we see in many nearby galaxies. Bright hydrogen emission from another extremely early system suggests photons escaping through, or around, an intergalactic medium still expected to be largely hostile to that escape. None of these clues says everything. Together, they point in a common direction. The first great lighting up of the universe may have had sharper local intensity than we had grown used to imagining. That phrase matters because it stays close to what we actually know. We are not saying the universe suddenly jumped from nothing to maturity in a single leap. We are saying that local regions may have become bright, chemically active, and environmentally influential sooner and more strongly than many earlier expectations suggested. It is a story of pockets, gradients, variation, and pace. And pace is where the human mind struggles most. We are good at stories that unfold one clear step at a time. We are less good at stories where many processes overlap. Yet the early universe may demand exactly that kind of thinking. A galaxy can still be very young while containing stars at multiple stages of life. The larger cosmos can still be mostly neutral while some local regions are already ionized. The first broad era of galaxy formation can still be underway, while individual systems are already becoming unexpectedly bright and enriched. This overlap is part of what makes cosmic dawn feel more alive now than it did before Webb. It also helps explain why caution and excitement can coexist so comfortably in good astronomy. The excitement comes from what the observations appear to be telling us. The caution comes from the recognition that frontier science is often full of subtleties. Sample sizes remain small, selection effects matter, interpretation of spectral lines requires care, and a distant galaxy is never a simple thing to decode. But caution does not erase the pattern. It just forces us to state it with discipline. And the disciplined version is strong enough. The earliest known galaxies are pressing on our assumptions about how quickly luminous structures appeared and how rapidly some of them evolved. That would already be enough to carry an entire story. Yet there is another reason it remains so compelling, and it has to do with the fact that we are not only studying objects, we are studying thresholds. A threshold is different from a category. It is the place where one state becomes another. In this case, the threshold is the passage from a mostly dark, mostly neutral universe into one increasingly structured by stars and galaxies, increasingly transparent to certain light, increasingly seeded with heavier elements. Thresholds are always emotionally powerful because they compress before and after into a narrow zone where change is visible. And Webb is looking directly into that zone. That is why the discoveries feel so personal even though the scales are absurdly beyond us. We recognize thresholds instinctively. Dawn instead of night, breath instead of silence, the moment a city starts humming before the roads are full, the first clear patch in a fog bank, the first sign that an empty house is being lived in. Cosmic dawn is that kind of threshold. And the surprise is that when we finally acquired the tools to see into it, we did not find a timid transition. We found signs that in some places the crossing may already have been well underway. That changes how the entire period feels in the imagination. It is no longer enough to picture the beginning as a quiet waiting room. We have to picture a place where local intensity mattered, where variation mattered, where some systems may already have been sprinting while the broader universe still looked unfinished. This does not make the story less coherent. It makes it more textured, more physically real, and far more difficult to reduce to a single smooth sentence. And that texture is exactly what pulls us toward the next question. If the universe could produce pockets of such early brightness and activity, then how common were those pockets really? Were we simply unlucky before, looking with instruments not built to see them clearly? Or were our expectations genuinely too conservative about what the first few 100 million years could hold? The answer will not come from one galaxy. It will come from the growing sample, from the gradual accumulation of systems that either confirm this picture or force it into a more nuanced shape. So each new detection now carries two kinds of meaning at once. It tells us about itself, and it tells us about the broader pace of the era it belongs to. That is why the frontier remains active rather than decorative. Every faint ancient system adds weight to a much larger argument about how quickly the universe learned to make light. How quickly the universe learned to make light may be the deepest question hiding underneath all of this, because light is never just light. It is evidence of organization. It tells us matter has fallen together far enough for stars to ignite. It tells us energy is being released in a stable enough way to cross billions of years and still be recognized. It tells us some region of the universe has already become structured enough to stop being merely potential. That is why the earliest luminous galaxies feel so consequential. They are not just old. They are organized old. They are bright in ways that imply underlying machinery, and the machinery is what presses on our understanding of the timeline. There is something quietly dramatic in that phrase. Learn to make light. Of course, the universe is not learning in any conscious way, but from our side of the story, it can feel that way. At first, there is a hot, dense beginning, then cooling, then atoms, then long stretches where gravity is setting the stage, and then, somewhere in those opening hundreds of millions of years, matter begins crossing a threshold where stars turn on and the darkness stops being simple. The universe begins to illuminate itself from within. Webb is showing us that this self-illumination may have become substantial earlier than we had emotionally prepared for. And once you start thinking in those terms, even a small change in the schedule begins to matter enormously. The difference between a luminous galaxy appearing at one time rather than a few tens of millions of years later is not a trivial update. Near the beginning, that difference represents a large fraction of the available developmental history. It is like comparing a child taking a first step at 1 year old versus on the second day of life. Both belong to infancy, but one completely changes the story. This is why distant frontier galaxies do not simply stack up as records. They act more like pressure points along the earliest timeline. Each one tells us how much complexity the universe was already capable of by a given moment. Each one narrows the range of what we can reasonably assume about the pace of early formation. Each one asks how much invisible setup must already have occurred before the light we see even left its source. That invisible setup is one of the most important things to keep in mind. When we detect a galaxy at around 280 million years after the Big Bang, we are not seeing the instant it formed. We are seeing it after however much prior time it needed to gather gas, form stars, emit radiation, and shape its internal conditions enough to become observable in the way it is. So the observation always points backward into an even earlier unseen interval. The visible galaxy is the tip of a prior story. That makes the pressure stronger. Because now the question is not just how active the galaxy already is when we observe it. The question is how quickly the unseen lead-up must have happened before that observation. How soon did gas begin to collapse? How quickly did the first stars appear? How fast did the radiation environment intensify? How early did the first enrichment begin? These are all hidden inside the snapshot. A snapshot can carry a surprising amount of history. It is similar to walking into a kitchen and finding steam on the windows, the smell of spices in the air, and a pan already hot on the stove. You did not see the preparation. You did not watch the ingredients being chopped or the heat rising, but the state of the room tells you work has already been underway. That is how these early galaxies behave. Their light is the state of the room. And the room is already warm. This matters especially when we remember that some of these systems appear not just luminous, but compact. Compactness means the action is concentrated. The stars, gas, and radiation are packed into a relatively small region. If you're trying to feel this physically, it helps to imagine the difference between a city's lights spread over a broad plain and a brilliant cluster of lights concentrated into only a few streets. The total brightness may be similar in some comparison, but the emotional effect is not. Concentration suggests intensity. It suggests a place where energy is being produced rapidly and in close quarters. That is one reason these galaxies do not feel like quiet seedlings. They feel more like dense young engines. And once you hold that image, the issue of the surrounding medium becomes even more powerful. An intense compact source inside a universe that is still largely filled with neutral hydrogen is not merely shining, it is confronting resistance. Its radiation is interacting with gas that does not simply let everything pass. So if certain photons are escaping, if signs of ionized conditions are appearing, then what we are seeing is not just luminosity. We are seeing luminosity with consequences. That phrase is worth staying with for a moment. Luminosity with consequences. Because it brings together the internal and external parts of the story. Inside the galaxy, stars are forming, shining, and altering the local chemistry. Outside the galaxy, that light may be beginning to carve or exploit pathways through surrounding gas. The object is not just glowing in private. It may already be participating in the larger transformation of the universe from a mostly neutral medium to a more ionized and transparent one. That is a very large role for something so early, and yet, this is where the script has to remain disciplined. We should not overstate what any single galaxy proves about the entire epoch. One object can be unusual, A few objects can tempt us into patterns that larger samples later complicate. The details of how quickly reionization proceeded, how patchy it was, and how much different types of galaxies contributed remain active areas of study. None of that weakens the emotional center, it just keeps it honest. The honest center is strong enough. Some of the earliest galaxies we can securely study look like they may already be doing substantial physical work. That sentence contains the whole mood of the discovery. Not simply existing, not merely glowing, doing work, forming stars at a meaningful rate, producing hard radiation, altering internal gas conditions, maybe beginning to affect the transparency of their surroundings, maybe carrying signs that earlier stars have already enriched the local material. This is not an untouched dawn. It is a dawn with labor already underway. There is a reason that lands so deeply. It changes the emotional meaning of origin. Origins are often treated as simple because that makes stories easier to tell. The first stage is basic, then the second stage adds complexity, then the third stage adds more. But physical reality is not obliged to honor our preference for neat narrative spacing. Sometimes the first visible stages are already dense with overlapping processes. Sometimes the beginning arrives faster than the tidy version of the story can hold. That may be what we are learning here. And if it is, then the implications do not stop with a handful of galaxies. They ripple outward into how we think about the formation of a later cosmic structure. A universe that assembles luminous pockets earlier may also begin shaping its later large-scale history under slightly different assumptions about pace and feedback. How radiation regulates further formation, how enriched gas changes later generations of stars, how local environments differ from one another. The earliest details can echo forward. This is one reason frontier astronomy feels so alive when it is at its best. We are not collecting curiosities. We are checking the opening conditions of a story that eventually leads to galaxies like the Milky Way, to stars like the Sun, to planets, to chemistry, to biology, to us. Not in a sentimental way, in a physically continuous way. If the first luminous systems behave differently than expected, then the whole cascade of the later history begins from a slightly different tempo. And tempo, once again, is the hidden subject. A slower opening produces one kind of cosmos. A faster, more locally intense opening produces another texture entirely. The difference may not overthrow the grand outline of cosmic history, but it can change the way every early transition feels. The move from darkness to light, from neutral gas to ionized patches, from pristine ingredients to enriched environments, from isolated first systems to a broader population of galaxies. Everything becomes a little less leisurely. That does not make the universe harsh, it makes it alive. And perhaps that is why these discoveries linger in the mind. They correct not just a technical assumption, but an emotional one. They remind us that the beginning may not have been a long quiet pause before the real story started. The beginning may already have been the real story, with gravity, gas, radiation, and chemistry moving quickly enough to create islands of intense activity, while the cosmos was still astonishingly young. If that is true, then each ancient galaxy Webb confirms is more than a distant object. It is a witness from a compressed era, carrying evidence that the first act of the universe may have entered motion earlier and with more force than we once found easy to imagine. Easier to imagine is often the enemy of what is true. The universe does not shape itself around the limits of our intuition. And one of the quiet gifts of astronomy is that it keeps correcting us without raising its voice. It simply places a fact in front of us and waits. A galaxy existed this early. It was this bright. Its light carries these signatures. Its surroundings may already have been altered. Then the mind has to do the slower work of catching up. That catching up can take time, because the ordinary language we use for cosmic history often hides the real intensity of it. We say, the first few 100 million years, as if that were a broad meadow of time. In one sense it is. By any human standard, it is incomprehensibly long. But near the beginning of the universe, those hundreds of millions of years are not a meadow. They are more like a narrow bridge. Everything that appears on that bridge arrives weighted. There has simply not been much time available yet, so any sign of maturity counts for more. This is why the phrase, only 280 million years after the Big Bang, matters so much. The word only is doing a lot of work. If we said 280 million years in almost any other context, it would sound like endless time. Continents shift in less than that. Entire branches of life appear and disappear within spans like that. But in the first opening stretch of a 13.8 billion year universe, it becomes startlingly short. It becomes a compressed interval in which matter had to gather, stars had to form, radiation had to flood outward, and perhaps already begin changing the medium around them. That is a lot to place on a narrow bridge. And yet the evidence keeps suggesting that the bridge held more traffic than expected. This is where it helps to think not just about what Webb sees, but how it sees. Ancient light is not simply faint because it is far away. It has also been stretched by the expansion of space itself. The universe has been growing while the light travelled, and that process shifts the light toward longer wavelengths. What began in shorter wavelengths long ago can arrive today deep in the infrared. Human eyes are useless there. Webb is not. It was built precisely to meet that stretched light where it arrives. That fact alone is worth lingering over. These galaxies did not suddenly become visible because they changed. They were always sending their light. We just finally built an instrument able to receive it properly. There is something deeply moving in that. The distant past was always speaking. We only recently learned how to listen. And when we did, what we heard was not quiet. It was not loud in any ordinary sense. Of course, the light is faint, the data delicate, the interpretations careful. But in the language of cosmic history, the message is forceful. The first luminous systems we can securely study are not whispering a story of reluctance. They are hinting at a story of early productivity. The universe did not dawdle before building some of its first bright structures. That word productivity may sound too modern, too industrial, but physically it fits. These systems were converting gas into stars. Stars were releasing energy. Some environments were being ionized. Chemical processing was already underway. Something was being made. Work was being done. The universe was not just expanding. In places, it was manufacturing complexity. There is a danger here of letting the story become too abstract. So let's keep a human picture close. Imagine being told that the oldest part of a city should contain only a few huts and the traces of foundations. Then you arrive and find not skyscrapers, but a cluster of lit workshops, smoke from chimneys, and roads already worn by use. The city is not complete, but neither is it in a quiet first moment. It is underway. That is the emotional correction Webb is forcing on us with these very early galaxies. Underway. That may be the most important word in the entire story. Because it lets us avoid two bad simplifications. One is the dramatic simplification that everything we thought we knew was wrong. The other is the dismissive simplification that nothing has really changed. Neither is satisfying. The stronger truth is that our picture of the beginning is becoming more active, more crowded, more overlapped, more ahead of schedule in certain places than we had once comfortably drawn it. And if you take that seriously, then the problem of abundance becomes harder to ignore. One bright distant galaxy can always be treated like an exception. It can be beautiful, puzzling, and still remain easy to mentally isolate. But as more bright systems appear in the first billion years, and especially as some are pushed very close to the first few 100 million years, the burden starts to shift. We have to ask whether the early universe was producing these luminous systems more readily than expected. That is not a trivial change. It affects how we think about the efficiency of early star formation, about the growth of the underlying halos that helped gather gas, about the balance between faint galaxies and bright ones in shaping cosmic dawn. It also changes the emotional texture of the era. A sparse dawn feels one way, a patchier but more populous dawn feels another. Think again of a foggy harbour. If there is a single lamp in the distance, you notice it. If there are several, appearing in different places, then the entire harbour begins to feel inhabited earlier than you thought. The darkness is still there. The fog is still thick. But the impression of emptiness is gone. That is what a larger-than-expected population of luminous early galaxies does to cosmic dawn. It steals back the comfort of emptiness. This is one reason the discoveries linger even in people who are not specialists. They activate a very old and very human instinct. We are deeply sensitive to signs of early occupation, a footprint on wet ground, smoke from a valley, a light in a window, evidence that a place we thought was empty is not empty. The early universe, as it comes into focus through Webb, is beginning to carry that feeling, occupied earlier than expected. And the occupation is not passive, It has consequences for the larger environment. This brings us back to the intergalactic medium, to that young cosmos still rich in neutral hydrogen. The broad picture has long been that after the first atoms formed, the universe entered an era in which neutral hydrogen filled space, making it difficult for certain photons to travel freely over long distances. Later, as the first stars and galaxies formed, their radiation began to reionize that hydrogen, gradually making the universe more transparent. This transition was never expected to be instantaneous. It was expected to be extended, uneven, and complex. Webb is not destroying that picture, but it is giving us reasons to think the local progress inside that transition may have been striking in some regions very early on. If bright hydrogen emission is seen from a galaxy at a time when the wider universe should still be largely neutral, then some explanation is needed. Perhaps the galaxy carved out a bubble around itself. Perhaps the medium was patchier, more porous. Perhaps both effects mattered. Whatever the final balance turns out to be, the emotional direction is the same. Even while the universe was still broadly fogged, some local lanterns may already have been burning hard enough to make themselves known. That is a beautiful thought, but it is also a demanding one, because once local lanterns exist, the beginning stops being generic, it becomes specific. One region differs from another, one galaxy races ahead while another lags, one pocket clears sooner, one system enriches its gas more rapidly. Variation enters the story early and forcefully. In a way, that makes the universe feel more familiar, not less. Our own world is like that. Growth is uneven, cities wake at different hours, storms break along different coastlines, spring arrives in one field before another. The universe is not a machine moving in perfect synchrony. It is a landscape of conditions, gradients, and local histories. Maybe that is part of what Webb is really revealing. Not merely earlier galaxies, but earlier individuality. Even at the dawn of structure, different regions may already have been living slightly different stories. That possibility matters because it keeps us from expecting a single elegant answer to every frontier observation. The early universe may not yield one clean tempo. It may yield a range, a distribution, a patchwork of onset times and intensities. Some galaxies may form and brighten very fast. Others may remain faint longer. Some may sit in environments that let light leak more easily. Others may remain wrapped in denser neutral gas. The common thread is that the first few 100 million years now look more textured than the smooth summary many of us carried before Webb. And texture changes meaning a smooth beginning can feel remote and simple. A textured beginning feels lived in. It feels less like a concept and more like a place where gas density mattered, where radiation had local effects, where chemistry began to diverge, where one galaxy's history was not identical to another's, a place where the phrase early universe stops functioning as a single mood and starts opening into a whole range of physical situations. That is why the title promise keeps deepening rather than fading. The galaxy is not troubling because it is far away. It is troubling because every detail we can extract from it becomes a pressure test on how quickly the universe could become internally active. Every new sign of brightness, enrichment, or environmental influence asks whether our older sense of the opening stretch was too calm. And calm may be exactly what it was not. Not chaotic, not violent in any theatrical way, just busy, intensely, locally, physically busy much sooner than our imagination had neatly arranged. And if that picture continues to strengthen, then what Webb is really changing is not just the map of the distant universe, it is our sense of what a beginning can be. What a beginning can be is one of those questions that seems philosophical until a telescope turns it physical. Then it becomes very concrete. A beginning can be dense with process. A beginning can contain overlap. A beginning can look unfinished from far away and still already be doing serious work. And once that idea settles in, the old picture of the early universe starts to feel too clean, too evenly lit, too patient. The new picture is not a replacement in the dramatic sense. It is more like a sharpening that changes the emotional weight of every line. The first galaxies are still the first galaxies. Cosmic dawn is still cosmic dawn. Rionization is still a gradual transformation, not a single switch. But within that broad structure, the details are getting harder, brighter, and more crowded. The opening stretch of the universe is beginning to look less like a quiet preface and more like the point where several major threads were already tightening at once. That matters because simplicity has always been one of our hidden comforts. It is reassuring to imagine that the earlier stages of everything were plain enough to understand at a glance. First this, then that, then the next thing. Yet the closer we look, the more that comfort begins to thin out. The first stars did not arrive in a blank emotional landscape. They arrived in a universe where gravity had already spent time shaping conditions, where local variations mattered, where some regions were already better positioned to race ahead. This makes the first galaxies feel less like isolated miracles and more like the visible tips of an underlying unevenness that had been there all along. That is an important adjustment, because it keeps the story grounded. We do not need impossible physics to feel the shock of these discoveries. We only need to accept that the ordinary laws of the universe, acting in the earliest dense regions, may have been enough to produce luminous, compact, chemically active systems sooner than many of us expected. The shock comes not from broken rules, but from underestimated efficiency. And efficiency is always easiest to miss when it happens far away. If a city across the valley appears dark, you may assume little is happening there. Then dawn comes, the haze lifts, and you realize factories were already working, roads were already busy, and windows had been lit long before you could make them out clearly. That is the quiet humiliation built into better instruments. They reveal that reality did not wait for us to see it before becoming complicated. Webb has done that on the larger scale. It has taken a stretch of time that felt almost abstract and turned it into a place with character. Not complete character, not fully resolved, but enough to feel. Enough to say that some galaxies near the dawn of structure were already luminous in a way that matters, already compact in a way that suggests intensity, already chemically suggestive in a way that points to prior stellar life, and perhaps already influential enough to shape how light moved through their surroundings. When several already statements begin piling up that close to the beginning, the pressure becomes impossible to ignore. Because that is really what the troubling questions are. They are the accumulated pressure of too many signs of maturity arriving too early for comfort. A single sign can be managed, a bright object, perhaps unusually fortunate, a strange line in a spectrum, perhaps needing cautious interpretation, a local environmental effect, perhaps not representative. But when brightness, compactness, enrichment, and possible local clearing begin travelling together, the timeline itself starts to feel crowded. And the timeline is the thing we can no longer treat casually. We are used to thinking of billions of years as the natural scale of astronomy, and in many stories that works well enough. But here, the meaningful action is happening inside much narrower windows. 10 million years matters, 20 million years matters. A few tens of millions either way can significantly alter how much prior star formation, chemical processing, and radiative influence you can pack into a system by the time its light leaves. Near the beginning, small shifts in cosmic age carry outsized interpretive weight. It is like watching the first light spread across a room. At midday, 10 minutes do not matter much. At dawn, 10 minutes can transform everything. A chair becomes visible, then the floor, then the far wall. The room is the same room, but the available information changes rapidly because you are close to a threshold. The first few 100 million years of the universe are like that. We are close enough to the threshold that even small temporal shifts have large consequences. This is why the frontier keeps pulling astronomers onward, not out of greed for records, but because earlier objects are more diagnostically powerful. A galaxy at a later time can always hide its formative struggle behind a larger budget of time. An earlier galaxy cannot. If it is bright, then the brightness must have been achieved quickly. If it is enriched, that enrichment began quickly. If it is already influencing surrounding gas, that influence started quickly. Earlier galaxies are harsher judges of our assumptions. And we need harsh judges at the frontier. That is how science improves. Not by floating in wonder alone, but by allowing reality to pin down where our intuitions were too smooth. Webb has been doing exactly that. Not in a theatrical way, in a patient one. One spectrum at a time. One confirmation at a time. One ancient system at a time. Slowly. The first chapter of cosmic history is becoming less of an idea and more of an observed environment. There is something moving about that, because for most of human existence, the beginning of the universe was not merely unseen. It was unreachable even as a meaningful thought. We could look up, invent stories, map stars, predict motions, and still have no instrument capable of directly receiving this kind of evidence from such an early time. Now we can stand on one small planet, beneath one ordinary atmosphere, and detect a light that left while the universe itself was still in one of its most formative intervals. And what we are learning from that light is not just that the universe existed then. We already knew that in the abstract. We are learning that it may already have been internally vivid. That word vivid matters. It does not mean fully mature. It does not mean settled. It means active enough to have a strong physical character, enough stars to matter, enough radiation to alter conditions, enough prior cycles to begin changing the chemistry, enough local contrast for one region to differ from another. Vivid is the right word for a universe that is still largely young and yet already developing bright pockets of consequence. This has a quiet effect on how we understand our own place in the timeline. We live late. That is obvious in one sense. The universe is old, and we arrived long after the first stars and galaxies. But late can carry a passive feeling, as if we merely inhabit the cooled remains of something that happened too long ago to matter emotionally. Webb complicates that. It reminds us that the late universe is full of messages from a beginning that was not passive at all. The calm sky above us is threaded with photons from an era that may have been astonishingly busy in specific places. So the distance between us and the beginning is not just temporal, it is emotional. We had imagined a certain kind of beginning. Webb is steadily teaching us another. A beginning where darkness was patchy with emerging light. A beginning where some systems may already have been racing ahead while others lagged behind. A beginning where local conditions mattered. A beginning where the first great transformation of the universe did not proceed as one clean line, but as a layered, uneven, accelerating field of events. And once you let that idea in, the night sky becomes harder to flatten into emptiness. It starts to feel historically dense. Not because every point of light is ancient in the same way, but because the darkness between the stars is no longer just absence in the imagination. It becomes the medium through which all of this happened. A universe that once held neutral hydrogen fog, then pockets of ionized clarity, then growing overlap, then broader transparency. A universe that did not leap from silent blackness to familiar structure all at once, but pushed through thresholds in a way that was likely more local, more textured, and more urgent than we used to picture. That is the real transformation Webb is offering. It is not merely showing us earlier objects. It is changing the feel of the earliest era from distant and generic to physically inhabited, active, and increasingly specific. And if that shift continues with the next generations of observations, then the beginning of the universe may end up looking less like a long, quiet waiting period, and more like a rapid, uneven awakening whose first visible traces were already brighter than we knew how to imagine. Brighter than we knew how to imagine, and perhaps that is the deepest service a telescope can perform. Not simply extending vision, but correcting imagination. We often think knowledge takes mystery away. In reality, the best knowledge changes the shape of mystery. It replaces a vague sense of distance with a more specific and more powerful unease. Not, there is something far away, but something far away was already this active, this luminous, this physically advanced, at a time when we expected much less. That is a better mystery because it is anchored. And anchors matter, especially in a story like this, because the temptation is always to drift into abstraction. Cosmic dawn, Ryanization, redshift frontier, early galaxy formation. These are useful phrases, but they can start to feel like labels floating above reality unless we keep translating them back into what they mean. A bright galaxy this early means stars had already formed in meaningful numbers. Signs of heavy elements this early mean some of those stars had already changed their environment. Evidence of strong ionization this early means the radiation field inside or around the galaxy was already intense. The escape of certain photons this early means the surrounding medium may already have been locally altered, or at least more porous than a simple smooth picture would allow. Each line is clean, each line is physical, and when they begin stacking together, the opening era of the universe starts to feel less remote and more specific. That specificity matters because it protects us from two kinds of laziness. One is dramatic laziness, where everything surprising gets turned into "science was wrong," The other is emotional laziness, where we hear frontier results and just sort of nod at the phrase "the universe is amazing" without letting the details change anything inside us. This story deserves better than both. The stronger reaction is quieter. It is the feeling of realizing that the first visible chapters of reality may have involved more local intensity, more overlap, and more rapid emergence than our earlier internal picture allowed. That is not a slogan. It is a recalibration. And recalibration is one of the most human things science can ask of us. Because our minds are built to work with middle scales, rooms, roads, seasons, lifetimes. Even when we think in grand terms, we usually smuggle familiar pacing into the universe. We imagine slow starts because slow starts make sense to us. We imagine simplicity at the beginning because beginnings in human stories are often simple. Webb is forcing us to notice that physical reality has no reason to honour those habits. A beginning can be compressed. A beginning can be crowded. A beginning can already contain consequences. This becomes easier to feel if we stop picturing the early universe as one evenly dark expanse, and instead imagine a huge landscape under fog with scattered regions already glowing from within. Most of the landscape remains murky. Many places are still dim, but some pockets are active. Some sources are burning hard enough to matter. Some local clearings are beginning to open in the haze. That image is not only emotionally stronger, it is closer to the kind of patchy, uneven transition many astronomers now think in terms of. That patchiness is crucial. It means the question is not simply, when did the universe become transparent? It is also, where did transparency begin first? Not simply, when did galaxies appear? Also, which kinds of regions got there earliest? Not simply, when did chemical enrichment begin? Also, how unevenly did it spread? Webb's most distant galaxies matter because they are not just timestamps. They are clues about the geography of emergence. And once emergence has geography, the story becomes much more alive. Because then the early universe is no longer one giant average. It is a field of local histories, some regions denser than others, some halos gathering gas more efficiently, some stars forming rapidly and flooding their neighborhoods with radiation, some galaxies perhaps clearing out ionized bubbles while others remain wrapped in thicker neutral gas. The broad epoch still exists. The local variation begins to dominate how it feels. This is one reason the results can sound modest in scientific language while feeling profound in ordinary language. A paper may speak carefully of luminosity functions, spectral line detections, ionization states, or unexpected number densities. Those are the right terms, but what they amount to, when translated honestly, is this. The beginning may have had more active neighborhoods earlier than we thought. That changes the sky. Not physically in the present tense, but psychologically. It changes what darkness means when you look up. It changes what ancient light means. Instead of an old and passive glow, you begin to sense messages from a period when the universe may already have been dividing itself into different fates, different environments, different speeds of becoming. There is something deeply calming in that, oddly enough. Not because it makes the universe smaller, it does the opposite, but it replaces vague grandeur with intelligible reality. It says, the universe is not only large, it is legible in pieces. Its early history is not just a blur beyond human reach. It can be tested, corrected, sharpened. Light from those first hundreds of millions of years can still arrive, and when it does, it can tell us that our earlier story was a little too smooth, a little too patient, a little too tidy. That kind of correction does not diminish wonder, it matures it. And mature wonder is quieter than excitement, but it lasts longer. It is the feeling of a map changing shape in your hands, not because the land suddenly moved, but because you finally have a better survey. The frontier galaxies Webb has found are like new landmarks appearing in a region once filled mostly with inference. They do not answer every question. They do something more valuable first. They force the right questions into sharper form. How quickly could the earliest substantial galaxies assemble? How fast could some of them become bright? How soon could stellar processing begin to enrich their gas? How patchy was the clearing of the hydrogen fog? How representative are the brightest objects of the wider population? How much of our older sense of cosmic dawn was shaped by lack of data rather than by the true character of the era? These are not disconnected puzzles. They all bend back toward one underlying issue. The opening timeline of the universe may have had less slack in it than we imagined. Less slack means less room for leisurely build-up, less room for the first stars to wait, less room for galaxies to remain merely embryonic, less room for the wider environment to stay unaffected for long in the brightest regions. That is why every earlier luminous detection feels so consequential. It is shaving time from the margin. And near the beginning, margins are everything. If you arrive at a fire 5 minutes after it was lit, you expect one scene. If you arrive and the room already bears smoke stains, glowing coals, and heat in the walls, then the fire either began earlier than you thought or burned faster than you expected. The analogy is imperfect, but the logic is the same. The state of a system tells you something about the rate of the processes inside it. That is exactly what these ancient galaxies are doing. Their present state, as observed in the distant past, tells us the lead-up could not have been slow in the simplest way. This is why even the uncertainties feel productive. We may still debate exactly how to model the stellar populations, exactly how strong the ionizing fields were, exactly how the surrounding gas was arranged, exactly how the brightest systems relate to the overall population. But those debates are not signs of weakness. They are signs that the observations are rich enough to matter. Thin observations produce thin arguments. Thick observations produce real pressure. Webb has begun giving us thick observations from an era once mostly hidden. And hidden is another word whose meaning changes here. The early universe was not hidden because it was unimportant. It was hidden because its light was stretched, faint, and difficult to catch. We lacked the ears for it. Now we have some of them, which means a part of reality that was once effectively silent to us is beginning to speak with detail. That detail carries an emotional lesson as well as a scientific one. It reminds us that the past was not waiting to become meaningful once we noticed it. It was already meaningful, already full of local urgency, already differentiating itself into pockets of brightness and changing gas, already writing complexity into the conditions from which all later galaxies, and much later our own world, would emerge. So when we say Webb spotted a galaxy so far away that it raises troubling questions, the troubling part is finally clear. We are not troubled by distance. We are troubled by evidence that the universe may have grown vivid with startling speed, that by the time we can first clearly see some of these systems, they may already have crossed thresholds we once imagined would take longer. And the more that picture holds, the harder it becomes to think of the beginning as simple. Instead, it begins to feel like a rapid, uneven brightening, a world still wrapped in fog but already full of labour, with certain regions racing ahead and making themselves known across almost the full age of time. Which means the oldest light Webb catches is not simply old. It is early and already busy. And that difference is everything. And that difference is everything because it changes what we think we are looking at when we look back. We are not looking at the universe in some pure childhood state, untouched and uncomplicated. We are looking at an era where childhood, if we insist on the metaphor, may already have contained work, change, and local intensity. That is a very different beginning from the one most people carry around without realizing it. It also changes the emotional meaning of the word primitive. In everyday language, primitive often means simple, underdeveloped, almost empty of character. In cosmic history, primitive should really mean early in composition, early in large-scale development, early in the long chain of a later complexity. But early does not stop matter from becoming locally intense. It does not stop stars from forming rapidly in favourable conditions. It does not stop radiation from changing gas. It does not stop the first signs of chemical history from beginning to accumulate. So the early universe may have been primitive in ingredients while already becoming sophisticated in behaviour. That is a subtle idea, but once you feel it, many pieces of this story line up more naturally. Of course, a very young universe would still be dominated by the lightest elements. Of course, many regions would still be dark, neutral, and difficult for certain photons to cross. Of course, galaxies would still be in the process of formation rather than settled into the calmer forms we recognize later. And yet within that broad young condition, some systems could already be moving fast enough to build brightness, mass, and internal complexity at surprising speed. The key is that youth and dynamism can coexist. That may sound obvious when stated plainly, but it is not how most of us instinctively imagine origins. We imagine them as sparse. We imagine a patient staircase. Webb is steadily replacing that staircase with something more like a slope, cut by pockets of rapid descent, places where gravity and gas found efficient ways to move earlier than the smoother picture encouraged us to believe. And because the evidence is arriving as light, there is something especially powerful about it. Light is immediate to us. We understand what it means to see a lamp in fog, a window glowing before dawn, a furnace colour in a dark room. So when astronomers say a galaxy this early is surprisingly luminous, or that certain spectral signatures imply intense ionization or enrichment, the translation into feeling is available. The universe is not merely present, it is active enough to declare itself. That declaration is gentle, but it is firm. It says that by roughly 280 to 300 million years after the beginning, some galaxies were not tentative smudges of possibility. They were systems already doing enough physical work to challenge our emotional timeline. The stars inside them had already turned on in force. The gas inside them had already entered altered states. The chemistry inside them had already begun to carry memory of earlier stellar lives. That is not decoration. That is history. And perhaps that is the most useful word to bring back into the centre now. History. Because history is what these galaxies possess more of than we expected for their age. Not history in the human sense of written records or layered civilizations, but physical history. Events already having happened. Conditions already having changed. Consequences already accumulating. A bright early galaxy is a body with a past. The farther inward we push the frontier, the more startling that becomes. Every earlier object gives us less available time while still presenting the same need for prior events. It is as though the universe keeps handing us finished clues from earlier and earlier in the day. At first light, the footprints are already there, the smoke is already in the air, the tools are already warm to the touch. The earlier the scene, the more those traces matter. That is why even one step farther back can feel so significant. The shift from a galaxy observed at about 330 million years after the Big Bang to one at roughly 290, and then to one at around 280, is not just a shrinking number. It is a tightening noose around leisurely explanation. Those lost tens of millions of years matter. They remove margin. They make every sign of maturity more expensive. And once maturity becomes expensive, you start looking differently at every clue. Compactness no longer means simply small, it means concentrated. Brightness no longer means merely visible, it means productive. Early oxygen-related signatures no longer mean just chemistry. They mean earlier stars had already changed their surroundings. Escaping hydrogen emission no longer means just detection. It means a struggle between light and a young universe that should still be difficult for that light to cross. The facts remain the same. The interpretive pressure increases. This is what strong science often feels like from the inside. The evidence itself can remain sparse compared with the immense story we want it to explain. But each piece arrives with more leverage than we had before. A few secure galaxies near the dawn of structure can do more to reshape understanding than many easy observations from later times, because the early universe is where timing is least forgiving. Forgiveness is a useful concept here. A billion-year-old galaxy can hide many processes inside its long history. A galaxy from the first few 100 million years cannot hide as much. It must reveal, by its very existence, that certain things happened rapidly enough to be seen. That makes these galaxies less like ordinary data points and more like demanding witnesses. They testify under conditions where embellishment is hard. If they are bright, they became bright soon. If they are enriched, enrichment began soon. If they are affecting surrounding gas, that influence started soon. Soon is the word that keeps haunting the story. Not in a frightening way, in a clarifying way. It is the word that turns distance into urgency. Not urgency for us emotionally, but urgency for the physics of the early universe. The stars had to ignite soon. The radiation had to matter soon. The first local transformations of cosmic fog had to begin soon in at least some regions. The opening act did not wait long before becoming consequential. That is why the frontier feels alive rather than complete. We are not merely adding ornaments to a settled history. We are actively redrawing the pacing of the first visible era. With each observation, the old image of a slow, dim, widely spaced beginning gives way to something more textured. Still dark overall, yes. Still young, yes. but already punctuated by compact, intense sources whose light can cross almost the full age of the universe and still tell us that the beginning may have come on faster than we thought. It is worth pausing here and letting the human side back in. Every person who has ever lived has lived under a sky whose deepest visible history was mostly inaccessible. We had myths, then mathematics, then optics, then larger telescopes, then space observatories, and still the first few 100 million years after the Big Bang remained mostly a conceptual region, not an observed one. Now the light from that region is arriving in enough detail for us to say something stronger than there were early galaxies. We can begin to say what kind of early galaxies some of them were. That is an extraordinary change in intimacy. The universe has not become closer in distance. It has become closer in character. Its earliest visible structures are beginning to seem less anonymous, not familiar in the everyday sense, but specific, distinct, already possessing conditions, already belonging to local stories inside a larger epoch. The first galaxies are no longer just placeholders in a cosmic timeline. They are emerging as actual systems with physical personalities. And physical personality is exactly what makes the story stay with us. A generic distant object is easy to admire and forget. A compact, brilliant, chemically suggestive early galaxy living inside a still foggy universe is harder to let go of. It has situation, it has tension, it has implications that reach beyond itself. Because once galaxies like this exist, the wider dawn cannot remain emotionally simple. The wider dawn becomes a place of uneven illumination, where some regions may already have moved ahead while others remained quieter. It becomes a place where early structure formation is not a distant abstraction, but a physically rich environment full of gradients, local differences, and emerging consequences. It becomes a place where the line between beginning and becoming is much thinner than we expected. And once that line thins, one last question begins to gather weight. If the earlier secure galaxies already look this active, then what lies just beyond them may not be a blank wall of simplicity. It may be an even narrower, more demanding interval, where the first sustained bursts of galactic life are just beginning to show themselves, carrying even less slack, even less room for delay, and therefore even more power to teach us what a true cosmic beginning really felt like. What a true cosmic beginning really felt like may always remain partly beyond us. Because feeling is a creature of the body, and no body could stand inside that era and experience it in any ordinary way. But understanding has its own kind of nearness. The more precisely we can trace what the first galaxies were already doing, the closer we come to replacing vague awe with something more durable. Not just wonder that the universe is large, but recognition that its earliest visible structures may have crossed into significance with startling speed. That is a different kind of intimacy. It means that when we talk about the beginning now, we are no longer speaking only in grand outlines. We are beginning to speak in states of matter, in the behavior of gas under intense radiation, in the presence or absence of certain spectral fingerprints, in the crowded brightness of compact systems, in the possibility that some of them were already opening clearings in a mostly opaque medium. These are not decorations on the edge of the story. They are the texture of the first act. And texture is what makes reality believable to the mind. For a long time, the earliest universe was too distant to have texture in any direct sense. It was a mathematical past, a theoretical past, an inferred past, beautiful, but still thin in the imagination. Webb is changing that. It is giving those first hundreds of millions of years edges and temperatures and asymmetries. It is showing us not a blank dawn, but a dawn with neighborhoods, not a single smooth brightening, but a patchwork of conditions, with some places apparently moving ahead faster than others. That patchwork may be one of the most important things to carry into the final stretch of this story. Because once you allow the early universe to be patchy, the troubling questions become easier to frame honestly. We do not need every region to be unexpectedly mature for the broad picture to change. We only need some regions to be active enough, bright enough, and chemically evolved enough to show that the old emotional average was too soft. A few early neighborhoods with the lights already on can change how the whole city feels, even if many streets remain dark. That is likely much closer to the truth of cosmic dawn than any image of a uniform universe steadily fading from dark to bright. The broad trend still exists, of course. The universe does move from more neutral to more ionized, from less structured to more structured, from chemically simple to increasingly enriched. But broad trends are not what telescopes like Webb are revealing most powerfully. What they reveal are the local exceptions that force us to redraw the average itself. And there is something almost tender in that process. Science, at its best, is not the destruction of a previous picture so much as the patient correction of it. We used to carry one version of the first galaxies in our minds. Now the light itself is arriving to tell us that version may have been too dim, too sparse, too relaxed in its pacing. The universe is not embarrassed by this. It simply offers more detail. The detail, in this case, keeps pointing in the same direction. The first visible galaxies were not merely beginning. Some of them were already underway in a serious sense. There is a quiet weight to those words, already underway, because they remind us that every observation is a delayed observation. Even a galaxy seen at roughly 280 million years after the Big Bang must have had a prior interval of hidden preparation. Gas had to collect, stars had to form, the internal radiation field had to intensify. If there are hints of enrichment, earlier stellar lives had to begin and end. If certain photons escaped, local conditions had to permit it. None of that appears from nowhere at the instant we look. So every early galaxy carries an unseen prelude. The earlier the galaxy, the more compressed that prelude becomes. That is what gives these discoveries their pressure. They narrow the hidden interval in which all the prior work had to occur. And that means the closer Webb gets to the beginning, the more severe the question becomes: how rapidly can an initially young cosmos generate a system that is not merely present, but physically expressive, bright enough to matter, distinct enough to leave signatures, active enough to alter its own conditions? This is why the story remains unfinished in the best possible way. We are not at the end of the frontier. We are at one of those rare points where the frontier has just become observationally thick enough to start resisting our simplifications. The next observations matter not because we crave more distant trophies, but because each one will help decide whether the current picture strengthens. Are these ancient luminous systems rare peaks rising above a mostly quieter landscape? Or are they signs of a broader early productivity that has only just begun to come into view? The answer may turn out to be something in between, as reality often is. A universe where some regions formed stars and brightened very rapidly, while many others remained fainter for longer. A universe where early ionized bubbles opened unevenly. A universe where the first substantial galaxies were not all alike, but already diverging in behavior and consequence. That kind of answer would not weaken the story. It would complete it, because it would make the beginning look not just faster, but more alive. Alive is an important word here, even though we use it metaphorically, not biologically alive, of course, physically alive, active, internally changing, responsive, a place where conditions were not static even while the larger cosmos still seemed young and unfinished. In that sense, the first visible galaxies are like pulses. They tell us where the early universe was already moving from possibility into expression. That is a beautiful thing to be able to witness from so late in the story. We live in a settled era by comparison. Galaxies are old. The universe is transparent. Heavy elements are common enough to build rocky planets and bodies and oceans and instruments and eyes and detectors. We arrive after most of the great transitions are long underway or complete. And yet from this late, quiet vantage point, we can still catch the ancient signs of those transitions beginning. We can still see the moment when the cosmos started to produce structures with enough intensity to write themselves into the dark. That perspective changes small things too. It changes the feeling of a clear night. It changes what ancient starlight means. It changes the emotional scale of our own existence, not by making us feel more important, but by making our lateness more meaningful. We are not early witnesses. We are very late witnesses. And because we are late, we get to reconstruct beginnings that were far more active than daily life would ever suggest. Soon the story will have to slow. It has earned that. But before it does, there is one last thing worth holding on to. The troubling questions raised by these galaxies are not an invitation to distrust science. They are an invitation to watch science become more exact in real time. A telescope sees farther. Farther becomes earlier. Earlier becomes tighter. Tighter forces better explanations. Better explanations change the feel of the universe. That is what has happened here. James Webb did not simply spot a galaxy so far away that it broke a record. It reached into a part of time where every sign of brightness becomes expensive, where every hint of chemical history becomes loaded, where even the escape of light can imply a local victory over cosmic fog. And what it found suggests that the universe may have started building visible complexity with more speed, more concentration, and more local force than many of us had comfortably imagined. Which means that when we finally let the opening of the universe become real in the mind, it may not look like a long, quiet wait for structure to arrive. It may look more like a dark landscape already under pressure, with pockets of light gathering, gas changing state, and the first galaxies making themselves known sooner than expected, as though the cosmos had no interest in lingering in simplicity for very long at all. For very long stretches of human history, the beginning of the universe belonged more to imagination than to sight. We could reason toward it. We could write equations that pointed backward. We could infer, but inference has a different emotional temperature from contact. What Webb has given us is not total contact. Of course, no telescope can hand us the first moments entire, but it has given us something close enough to matter deeply, light from a time so early that the universe was still in the act of becoming itself, and that light does not describe a beginning as quiet as many of us once pictured. It describes a beginning already in motion. That is the line I keep coming back to, because it gathers everything without forcing it. The galaxies Webb has helped confirm at the redshift frontier are not troubling because they are distant trophies. They are troubling because they seem to belong to an era where simplicity should still have had more control, and yet the details we can extract from them suggest brightness, concentration, chemical processing, and perhaps local environmental influence arriving with surprising speed. Not impossibly, not magically, simply sooner, and in some places more forcefully, than our older inner picture allowed. There is something very calming about being able to say that clearly. Not because the mystery disappears, it does not. We still do not know every detail of how the earliest luminous systems assembled so quickly in the brightest cases. We are still working through how representative these galaxies are, how patchy the surrounding medium was, how early enrichment spread, how the faint and bright populations balanced the work of reionization, how stellar populations behaved under those opening conditions. Those questions remain alive. But the center of the story is no longer vague. The center is this. By the time the universe was only a few 100 million years old, some galaxies may already have been doing much more than simply existing. They were shining hard enough to be found across almost the full age of time. They may already have carried the traces of earlier stellar life. They may already have been helping open local windows through a still difficult cosmos. And because they were so early, every one of those statements lands with extra weight. It changes the mood of the beginning. That might be the most lasting effect of all this. Before, many of us carried a beginning that felt thin and distant, a long dark preface before the real richness of cosmic history began. What Webb is giving us instead is a beginning with pressure in it, a beginning where gravity had already found its footholds in some regions, where gas had already collapsed efficiently enough to light stars in force, where those stars had already begun altering their surroundings, where the larger darkness still held but no longer held evenly. A beginning with texture. And texture is what makes the universe feel real. A smooth story is easy to repeat. A textured story is harder to forget. You can feel the difference between saying, "the first galaxies formed," and saying, "some early galaxies were already compact, bright, and physically active in ways that compressed the timeline." The second one carries weather. It carries resistance. It carries the sense that local conditions mattered, that one region of the cosmos could already be racing ahead while another remained quieter and dimmer. That is a more humanly satisfying truth, even if it is less simple. Because our own world is like that. Dawn does not arrive everywhere at once. Cities wake unevenly. Fog thins in patches. Histories diverge from shared beginnings. The universe, when it becomes visible in enough detail, turns out not to be less specific than life. It is more. And that is where the emotional meaning of Webb's discovery really settles. Not in spectacle, but in witness. We are a very late species. We live in a comparatively calm era, under a sky whose violence and urgency are mostly hidden by distance. We arrived after the first stars, after the first galaxies, after the great transitions in transparency and chemistry and large-scale structure were already long underway or complete. Yet lateness brings one extraordinary privilege. We get to look back. We get to receive photons that left when the cosmos was still in one of its earliest readable chapters. We get to notice that the chapter was denser than expected. We get to revise our picture of reality not because it flatters us, but because the evidence asks us to. There is humility in that, but not the empty kind, not the kind that says we are small and therefore nothing matters. The deeper humility is stranger and better. We are small, yes, entirely non-central, but we are also present late enough for the light to arrive, present clever enough to build instruments that can read it, present patient enough, on our best days, to let a difficult fact slowly change the shape of our imagination. That is not centrality, it is participation. And perhaps that is the final gift hidden inside these galaxies. They remind us that knowledge is not cold distance from the universe. It is a form of contact with it. A galaxy shining less than 300 million years after the Big Bang is not just a line in a paper, not just a redshift value, not just a record pushed slightly farther back. It is contact with an era when the universe may already have been more urgent, more productive, and more locally alive than we had once found easy to believe. The ordinary sky becomes richer after that. Not louder, not more theatrical, just richer. The dark between the stars no longer feels like empty black backdrop. It begins to feel historically inhabited. It held the neutral hydrogen fog. It held the first local clearings. It held compact young systems turning light into influence. It held the first heavy traces of stellar history spreading into gas. It held a universe that did not remain simple for very long. And from here, from one quiet world in one mature galaxy, we can trace that. That is a beautiful thing to be able to do before sleep, or in the middle of an ordinary night, or at any moment when daily life starts shrinking reality down to the size of immediate concerns. Because reality is larger than that, not only in scale, but in pace. It became intricate quickly. It became expressive quickly. It may have become vivid long before our older stories were ready to let it. So when we say James Webb has spotted a galaxy so far away that it raises troubling questions, the final truth is not really troubling in a fearful sense. It is troubling in the best sense. It troubles a picture that had become too simple. It loosens our grip on an easy beginning. It asks us to replace the old smooth darkness with something more honest. A young universe still wrapped in haze, already punctured by pockets of light, already generating consequences, already writing history faster than comfort preferred. And that, in the end, is why this matters. Because the beginning of the universe was not just distant. It was active. Not just ancient. Already underway. Not just dark. Busy with the first difficult work of becoming everything that would follow. And now, after all that time, some of that first work has reached us as light. We can sit beneath the calm of a modern night, look up into what seems like silence, and know that the silence is only what great distance feels like from here. Far away, long ago, the first galaxies were already making themselves known, and against every ordinary scale of human life, we are fortunate enough to be here when their message finally arrives.